Hey everybody, this is Larry, this is me coming Q3 of the weekly contest 422. Find minimum time to reach last room 2. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. First of all, what I did for the third problem, and I solved it in, actually 3 minutes feels a little bit long, but I think I was just double checking things honestly. Wow, people solved it really quickly. But I would say that for this is what I did was copy and paste Q2 solution and then made a little bit of modifications. So to really understand this problem, check out my Q2 video. I'll have it in a link below somewhere. Make sure you understand the Q2 first, right? And not just understand it because you may have solved Q2, but if you have solved Q3 and you understand it, the constraints are a little bit different, so definitely check out my explanation of the Q2 the way that I did it first. Before feel free to ask questions anyway, but these are my prereqs, right? So the first thing to note is that you have this change where the cost function is a little bit different. Instead of 1 second, it's 1 second and 2 seconds for the next, alternating between the two. So yeah, and then the second difference is that there are a lot more nodes. It's 750 times 750. So now what is that actually? Like 100,000, I think, something like, or like a little bit less than 100, or a little bit less than 500,000, or a little bit more than 500,000, I guess. Anyway, because 707 is 500,000. 707 squared is 500,000. Anyway, my point is that this is way big, so you have to be a little bit or a lot careful, But however, there are a couple of observations, right? The key thing to note is that the number of edges is still not that big, because it's not a v-squared dense graph. In fact, it's a very loose graph, right? Each node only has 4 edges, so even though you have 500,000 nodes, it's relatively okay. It's very doable. The other thing is the same thing as what I said, Q2. Don't confuse this with dynamic programming. You can sneak around. I don't know if that's probably a test case in Q2 anyway. So definitely, I don't know. I didn't do it the wrong way to know what the pitfalls are, but this is not dynamic programming. And this one will be Dijkstra's algorithm. This code, actually, I'm going to pull up Q2 real quick, just to illustrate how close it is. This is my Q2, and this is my Q3. And honestly, you can see that it is very much the same, pretty much. The only thing that I added, and I'm going to highlight here, is this line. This is the only line where I changed the function of this is here I +1 and +1. Here I changed it to a p, and I did a +p and a p, right? A p, initially I did p for parity, like 0 and 1 and 1 and 2. That's the reason why I called it a p. I don't know. It's just what it is. But yeah, before I start though, if you're getting timeout, the first thing you need to do, if you already did Dijkstra, I assume that you already did Dijkstra, because dynamic programming is just probably wrong unless you're a little bit silly. There are 2 things, right? One is that you have this line is very easy to miss. I explained this line in the Q2 video, so definitely check that out. I actually put in a little bit more detail, but the short answer is that so that each node gets relaxed only once. So if you're getting timed out at this point, you need something like this to make sure each node gets only once. I think another way to write it is something like use this equal to. Another way to think about it and write it, I might as well do it really quickly, is just something like this, where if xy is already used, then we just continue, otherwise we set it to use. Pretty straightforward stuff, honestly, if you understand it, but again, I explained it in the Q2 video. So now I'm going to just take it out for now. And suffice to say that this line is what competitive people do, just because competitive programmer, not just competitive per se, just because it's just, I don't know, that's the way that I've always done it, so that's, it stays, but and obviously you don't need an extra variable as well. But in any case, so the 2 ways that you can actually solve this problem, I briefly debated solving it the other way. So the other way to think about this is to, when you watch the live portion, you could see this, is to elevate the dimension, right? What do I mean? Well, there are only 2 different. The initial thought was that there are only 2 things, right? One is that the last step that you took 1 second, or the last step that you took 2 seconds, right? So those are the two things. So those are the states. If you think about them as states, then now you can just store that into a new node. So now instead of R times C number of nodes, you have 2 times R times C of nodes, and one set of nodes is if the last step taken was 1 second, and the second set of node is that the last set of nodes taken, or last step taken, is 2 seconds, right? And this kind of matches the alternating thing. I did actually was about to implement it this way. I don't know if it times out or not, because I think it actually, because it goes from about 500,000 nodes to 1 million nodes, and 1 million is a lot of nodes, is what I was going to say. But and I don't know if it times out or not, but that is a correct solution. But also a little bit like, I feel like Leetcode is a little bit stingy with the bounds to kind of make it like a little. It feels too tight, even if it gets accepted, is what I would say. Like, I don't know if it gets accepted or it times out, but yeah. I think that's just as they say, not a great move, in polite terms. But yeah. So then the second thing is, well, then how did I end up doing this thing? And this is literally, you look at, this is my Q2, this is my Q3. All I did is added this line. Instead of +1, I did +P and +P here, and that's it. Everything else the same. Everything is Dijkstra. You could go to Q2 and look at it, but why, or what does this mean, right? Okay, so the key thing to note is that to make this observation is that well, you don't actually need to double the you don't need to increase the dimension. You don't need to double the number of nodes and increase the dimension. You can actually take a look at this thing, and give me a second. I'm just bringing up the drawing board. Where is it? Okay, there we go. Yeah, so the idea here is that now, because it's alternating, what does that mean, right? Alternating means that, okay, let's say we have a thing. Well, we have a thing, I'm too lazy to draw it out. I need like a default dashboard thing, or like a grid thing, so that I could just copy and paste it or something. So let's say you have a grid, right? What happens? Well, the thing is that now you can think about it as a checkerboard, really, right? And what I mean by that means that this, okay, maybe not that. I didn't fill it out enough. Okay, so this, I mean, I'm just going to draw a few more, but you know what oops, not that one. This one for X, but you get the idea of what a checkerboard is. Even though I didn't draw all the things because of that, stuff like that, but you get the idea, right? Alright, so you know what a checkerboard is, right? The thing is that, well, it is the same idea here as a checkerboard, is that when you go from a white square, you always end up at a black square, right? And when you go from a black square, you always end up at a white square. That is, obvious. But now, instead of black and white, think about these as going, let's say, another way to phrase it is going to a black square. It takes 1 second, and then going to right takes 2 seconds, right? So if you think of it in that way, then now every alternating move is going to be from 1 second, 2 seconds, and so forth, and there's no way to go around it. And then now, once you think about that, then now you just try to figure out if we are going to a black square or a white square. The actual colors don't matter, because, I don't know, I mean, you could flip it, obviously, right? So that's really the idea here for this problem. And as you can kind of figure out from a little bit, and the way that I figure it out is just from experience, right? Is that if you kind of just look at the diagonals, then the black squares will be on the, when nx plus ny is equal to, when x is, when they are not the same odd parity, then they're odd or something like this. But I mean, I'll leave it for you to figure out at home. But this will give you either a 0 or 1, denoting whether it is white or black. And then I just take 2 from it, right? So it goes from 0 and 1 to 2, 1 and 2, and which is the cost that we want. Yeah, and the only other thing is just to make sure that you get it right, meaning that you just do the math to make sure that if you're going to 1 0, the way that this is what I did in my head to check, like if I was going from 0 0 to 1 0, well, the first step is going to be 1 second, right? So I plug this in, I go, okay, this is 1, this is 0. So this is going to be 1, so that is going to cost me 1 second. So that's how I verified that this is at least correct for the first one. And then from 1 0 to 1 1, say, then this is going to be 1 plus 1 is equal to 2. This is going to be 0 because it's mod 2, and then this is going to be 2, and this is what we want. And that's pretty much it. What is the complexity here? This is regular dice complexity, which is relog yi. It is not that fast, but yeah. But in general, this is, this should be good because a lot of the states are not reachable in the beginning anyway, because this, So yeah, that's pretty much it. That's the idea. And yeah, that's all I have with this one. You can watch it, or you could watch me solve it live during a contest next. One, no. Okay. How many people have gotten this one? I was a little bit slow on it, honestly. Okay, let's see what's the difference now. Oh, moving, Jason between 1. Okay, I mean, that's fine. 9 people got it already. Okay, so this is not going to be right, obviously. So I just want to submit it, or not submit it, but okay. So then now we just need we want a 2 on it. I hate Actually, you don't even need to. This is just parity is always depending on the cell. Oops. Yeah, okay. Or maybe just oh wait, it's 2 seconds for the other one, right? Okay, well, let's see. So the first move is 1. So yeah, this is right. It's plus P. 764. Am I right? I mean, it is right, but am I confident? Let me double check my silliness. At least 2 cells. Okay, whatever, YOLO. Okay, 2 people's got this already. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, the problem, the explanation, everything in between. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.